Hello and welcome back to the Aimless Electron. In this episode we're going to take a look at the next part in our DIY reflow oven project, and that has to do with the AT commands. I'm going to show you a finite state machine that I use to set up the capturing of the commands, and then we'll look at the code to see how I decode them. So now let's hop over to the computer and check out that diagram. While the microcontroller is running, it can receive an interrupt from the USB port. In that case, we go over to our command decoder as our event handler in a sense, and this is the finite state machine diagram for that command decoder. If it's in the waiting state, that means we're at the very beginning and we're waiting for an A to be entered. Now the A can be uppercase or lowercase, it doesn't really matter because it will be converted to uppercase. If anything else is entered, it just loops back around and stays in that waiting state. If A is received, we then go to the A received waiting state and we wait for a T. If anything but T is entered, it goes back to the waiting state. That way you can type in anything you want, but until you type in A, then T, you don't go any further. Once T is entered, we capture any A through Z, in other words alpha characters, and store them in a little buffer for the command itself. Once entered is hit, then we process that command as an execute command. And that means we just treat it as or as a command to issue to the oven. If equal is set, then we are moved into our set receive state, which means we wait for a value to set something inside of the oven, and once enter is hit, then we process that command and set some value in the oven. Finally, we can get a question mark and then perhaps another parameter where we again wait for an enter to be received in our query receive state. This is just pulling a value from our oven to find some information out about it. Once these commands are executed, it goes right back to the waiting state. Now let's take a look at the code that handles that. Back in the code for our project, you'll notice that there's a couple new files here. The first one I want to go over is this oven.h, because the oven files will basically be the high-level values for the oven itself. And the first thing we have is the status enum for the oven, which basically holds the state of it. In other words, it could be stopped, just powered on, not doing anything, running where it's actually running a profile, or it could be in one of these test modes. It also has this external global variable which will be used for everybody to see the status of the oven or set it. Finally, in the oven.c file is where we create the variable itself. Moving over to the command.decoder.h file, I have all these defines for the AT commands themselves, and we'll come back to this and I'll tell you what the commands do and their purpose and the different modes that they can be in. I also have these strings set up that are messages back to the user or whatever is using the serial port when setting the commands as kind of like error commands or status commands. The one I don't have in here is the one that says unknown command. I may put it in here instead because I don't like magic strings that are buried in code. Next I have this command state enum, which is actually the state that we saw inside of our finite state machine for the command decoder. You'll notice the waiting, the A received, T received, the query received, and set received. Finally, I have the declaration for this process input method, which is our event handler in a sense. It's our callback whenever we receive a character from our USB connection. Inside our command decoder.c file is where all the magic happens to collect the commands and actually execute them. The first thing we have is the actual state itself. Then we have this command modifier variable. It's just for storage, and I don't actually use it for anything else, but I may, so I put it in there. Then we have an array to store the command itself, and then an args array for any arguments to like the set command. Finally, I have this index, which is just my way of storing the characters in the correct spot in these arrays. I created these two print status methods just so it was an easy way to say back to the user or back to whatever's calling the or inputting information that the command needs to either be in a or the oven needs to be in a specific state for the command to work, or the oven is in a state that it cannot be for the command to work. Next, I have these three methods for processing executable commands, processing query commands, or processing set commands. The only thing that's in here right now is test code, except for checking the status of the oven itself. If the command isn't recognized by whatever one of these methods it's in, it'll print out unknown set command, unknown query command, or unknown command. It's really just a test right now to make sure my command decoder is working, and then eventually the commands will do something useful, but that'll be next. I have this little toUpper method as well, which just converts any character to an uppercase character if it isn't already. Finally, I have the process input command. This is where all the magic actually happens. I convert the character into an uppercase character if it can be. That's the very first thing I do. Then we check the state. If we're at the beginning, if we're in waiting, we look for the C to be an A, the character to be an A. And if that's the case, we move on to A received. Then we look for it to be a T when the next character is entered. If it's not, it goes right back to waiting. Otherwise, we clear or clean up our command and args arrays and move on to T received. And T received, we look for either a question mark, an equal sign, a character, or enter to be pressed. Otherwise, we just stay inside T received and don't do anything. If it's a question mark, we set this command modifier, but again, I don't use it for anything right now. It just might be for future use. I can always delete it later, but we do set our state to query received. Same thing for the equal sign, except we set the state to set received. If we're just entering characters, we fill up our command array unless we're already past the 8 mark for our index, which means we're not going to overrun our array. And finally, if we hit enter and we've got we've got at least one character in our command, we go to process it as just an executable command and go right back to waiting as our state. Inside the query received, even though we had set it up to be able to receive some other input as arguments, I'm not doing that yet, so I'm just leaving this waiting for enter to be pressed. Otherwise, it doesn't do anything else until enter is pressed. And then finally, when it is, we process that query command, reset to waiting, and clear out our index. Finally, in the set received, we again wait for enter to be pressed. Otherwise, we wait for characters of anything to be entered into our arguments. So we can have alphanumeric, whatever we want, as long as, again, the index is less than 32 so we don't overrun our array. And that's pretty much it. Before we look at this working in the terminal, I wanted to go over what the AT commands actually are. We have a log on and a log off, and that means that there's a continuous log I plan to have running every time it takes a measurement that it can spit out, so you can log this on the computer itself, and this just turns it on and off. And that's just a set command. There's going to be a temp command which you can use to set the temperature or get the current temperature. And when you're setting it, it can only be in the stop mode or a test mode. There's going to be a time, which is actually only a query. You can't set the time, but you can query like what the current runtime is, or the actual runtime, whatever you want to call it. I have a heater top and on and a heater top off, which just means you can turn the top heater on or off, and same for the bottom. And those are only set commands, and they can only be run in certain modes, like when it's stopped or when it's in a test mode or something like that. And then I have the heater top and heater bottom, which gives me the status. So these are just queries. That's the only way they'll work. I have the same for the fan, which is a query to tell me if the fan is on or off, and then I have these two set commands to turn the fan on or off. Again, only if it's in a test or stop mode. I have this backlight query command, which just tells me if the backlight is on or off, and then the ability to turn the backlight on or off. I have a profile command, which sets the current profile or returns what the current profile is. I have a run command that will only work if this profile is set, and it'll run whatever profile is in there if we're currently in the stop command or stop state. The stop command will basically stop whatever profile is running, but of course it has to be in run mode. The status returns the status of the oven currently. That's all it does. And then I plan to have these calibration modes where you can calibrate it in a high, medium, and low state for the temperatures, and these are either set or query commands. The backlight on time command, I wanted to add this so that you could set how long the backlight stays on for the screen. In other words, you don't want it always on. Although if perhaps you set it to 0, that means it stays on indefinitely. Otherwise, it stays on for X number of seconds. And this is going to be a query command or a set command. Then you have profiles, which returns all the profile names that are currently stored on the microcontroller's flash. Then you have this profile config, which means you can add configurations in a time/temperature mode, and it will store it for the current set profile. Then you have profile delete, which deletes the current set profile. Finally, the stop all command, which just basically halts everything that it could be doing if it is doing anything and puts it back into stop mode. That's the AT commands. Let's take a look at the terminal real quick, and that'll be it. Now for a quick demo in terminal, just to show that our command decoder is working. If I type in something like AT hello and I press enter, that's not a real command, so it just returns unknown. But if I type in something like AT log off, which is a real command, I get log off back just to show that it decoded the correct command. But remember, some of these are dependent on the state of the oven itself to work. So if I type in something like AT log on, I get status must be running. In other words, this has to be running for me to actually run the log. Finally, to test something like the set commands, I can try AT temp equals 123. And I get back temp equals 123. And that shows me that it recognized my command and the input that I gave it. So that's really it that goes into decoding those commands, and on the next episode I'll probably have added some hardware, which I'll show, and some more code to control things and maybe set some of the statuses, turn some things on and off. Please come back, check that out. But in the meantime, give me a thumbs up if you liked it, hit the subscribe button, and let me know in the comments what you think, or if you'd like to see something, or if you have some questions. Anyways, that's it for now, and I'll see you in the next one.